All right, today we're going to take a tour of one of the most vital, hardworking, and honestly, incredible organs in your entire body, the kidney.
And I want to kick things off with just one number, a big one, 400 gallons.
So what's that all about? Well, 400 gallons, that's how much blood your kidneys filter every single day. To put that into perspective, that's like taking all the water in a large hot tub and running it through a filter day in and day out. It is an absolutely staggering amount of work for two organs that are, relatively small.
But here's the thing. Just saying they filter waste, that really doesn't do them justice. They aren't just simple strainers. Nope. A much, much better way to think of them is as your body's master chemist.
This analogy, it really hits the nail on the head. The kidneys don't just throw things out. They are meticulously analyzing your blood, deciding what to keep, what to send back, and what to get rid of, all to maintain that perfect chemical balance your body needs to survive.
So, to really understand this incredible plant, we need to know what it looks like and where it is. So, let's start our tour with the kidney from the outside.
And here are the basics. You've got two of them, positioned on either side of your spine and kind of tucked safely just below your rib cage. They have that famous bean shape, which is exactly why we have kidney beans. And each one is only about the size of your clenched fist. Pretty compact for such a powerful machine, right?
So that's the outside. But the real magic, all that complex machinery, is happening on the inside. So what in the world is going on inside this small, bean-shaped organ?
To find out, we're going to, metaphorically slice one open and take a look inside at its major zones.
You'd immediately notice two distinct regions. On the outside is the lighter-colored renal cortex. This is ground zero, where the initial large-scale filtration of blood begins. Then, deeper inside, you see the darker, reddish-brown renal medulla, which is just jam-packed with millions of tiny tubes that are collecting and processing all that filtered fluid.
And right at the very center of it all, you find the renal pelvis. The best way to think of it is as a funnel. Its entire job is to collect all of that processed fluid from those countless tubes in the medulla before sending it on its way out of the kidney.
But even these zones are just the large-scale geography. The real work, the true heavy lifting, happens at a level you can't see with the naked eye. We need to zoom in, way in, to find the microscopic powerhouse of the kidney.
And here it is, the nephron. If you learn one word today, let this be it. The nephron. This is the microscopic structural and functional unit of the kidney. Everything we've been talking about, filtering, recycling, balancing, it all happens right here in this one tiny structure.
And how many of these tiny powerhouses are packed into each kidney? Over 1 million. And that's not in total. That's over 1 million nephrons in your right kidney and another million in your left. It is an absolutely incredible feat of biological engineering.
So how does a single nephron work? It's a brilliant two-step process. First, you have the filter. Blood enters a structure with a tiny tangled ball of capillaries called the glomerulus. Just think of it as a high-pressure sieve. Then comes the processor, a very long, twisting tube where the real intelligence of the kidney shines. It reabsorbs everything your body needs, like glucose, water, and salts, and lets the waste products continue on their journey. Okay, let's put it all together now. We've seen the outside, the inside, and the microscopic engine. Now for the full filtration story, tracing the path from start to finish.
Let's trace the path. 1. Blood enters that high-pressure sieve, the glomerulus. 2. Water, waste, and other small molecules are forced out into the tubule. 3. As this fluid travels down that long winding tubule, those essential substances are pulled back into the blood. 4. The leftover fluid, now concentrated waste called urine, flows into a collecting duct. 5. Many of these ducts merge and funnel that urine into the renal pelvis, that central collection area we saw. And finally, step 6. The fluid exits the kidney through a tube called the ureter, on its way to the bladder for storage.
And the most amazing part? This entire complex process is happening simultaneously in millions of these tiny factories, all working in perfect concert, 24 hours a day, 7 days a week, to keep your entire body in a state of perfect chemical balance.
So we've seen how this incredible system is built, but it leaves us with a final crucial question. With 1 million of these tiny, delicate filters working tirelessly in each kidney, what happens if they start to fail? It really puts into perspective just how vital and perhaps how fragile this internal balancing act truly is.